Morning to all. So is my audio am audible? Good morning to all. So I'm audible, right? So the last class we discussed about the basics of your data intensive computing. So now we will discuss with respect to what is all about your history perspective with respect to the data computing. Okay. So now how the data evolution has been occurred. So mainly we discussed in the last class that what the data intensive computing involves. So it's basically involves what? It's basically involves the production, management, and analysis of larger volumes of data. Either it may be in internet or it may be in your through the internet also it can produce the data, or through the scientific experiments also it can produce the data. Okay, those data has to be managed and it has to be used for analysis purpose. Okay, so now suppose support for data intensive computations, what you are going to have, it is going to be provided by what? By having the different technologies like storage, networking technologies, algorithms, and infrastructure and software all together combinedly they are going to provide you the data intensive computations. So what are the different support they are going to have according to the history if you go with that one? So the history tells that in the earliest they are going to make use of the wide area networking. Okay, so after that one the data grids are evolved. So with the help of the data grids they are going to have to connect to the two different have connected with the different part of the world, and they are going to do the computation with respect to the distributed infrastructure. Okay, so next is data clouds and big data came into existence. So once the data clouds and big data came into existence, so with the cloud they are going to manage, and with the help of the big data and machine learning algorithms they are going to make use of those data, and they are going to analyze effectively. So when you are going with the machine learning algorithm, so even the machine learning is going to this deal with the big data only, but only thing is it is going to uh, go to the accuracy, nearest accuracy. It is going to provide you the data or prediction what you're going to have. So that prediction using the machine learning algorithms, so you're going to have the accuracy which you're going to have. So now when it comes to the early age networking, so in this particular early age networking, what will happen? What has happened? So it is the basic evolution of technologies. It is going to happen. So in that particular technology, what has been came there? So there came the protocols, and then algorithms came into existence. For what purpose they have been protocols and algorithms has been invented there? So the protocols and algorithms were invented with the for the purpose of data transmission and streaming. So for purpose of data the transmission and streaming, they are going to make use of the protocols and algorithms. So basically, if you take the high-speed wide area network, so it is going to make use of the TCP/IP based distributed application. So your if you take your wide area networking, so there it is going to make use of TCP/IP based distributed applications. Okay, and that was been demonstrated in real time using in supercomputing 1991. Okay, so it is going to be the first data intensive environment. So it is to report it to a magic project. Okay, so it is a defense organization, DARPA funded collaboration. So DARPA is the one of the defense organization in USA. Okay, so in that particular with the help of that particular defense for the defense purpose, so they are going to make use of the data intensive environment. So and that particular project is called as magic project. So it is basically works on the distributed applications in large scale. Okay, so it basically works with the distributed application in large scale. So where the high speed data networks are required. Okay, so next when it comes to the distributed parallel storage system was developed. So after he were DARPA funded distributed applications environment. So it is we are going to develop about distributed parallel storage systems. Okay. So in the distributed parallel storage system was developed, which was later used to support TeraVision. Okay. So next, in this particular early age, what you are going to have is, so apart from these important points, so it's going to provide you the remote visualization of large and complete data set. So in this particular data set, it's going to have the complete visualization. So complete visualization will be there for the large and complete data set. So you're going to have the different data set. The data set may be either structured, unstructured, or semi-structured. Okay. So when you are going to have this type of data, so this particular setup, the data using your that particular data has been used in some of the researchers. So where that particular research is, uh, where the research and distributed environment which they want. So they have set up that particular environment in Pittsburgh Supercomputing Center. Okay. So with that particular terminology, they are going to exchange the information. So the next is the challenge addressed by the Clipper project include. So the management of substantial computer resources will be there. Generation of computation of high rate and high volume data flows will be there. Okay. So that is about your early age. So next, at the last, when it comes to the early age, so the Kepler project came into existence. So now in the Kepler project, what they made is, so they made available a remote data sources. So they made the availability of the remote data sources with high data rate. That means what? So I can access the database which is stored in remotely, which is stored remotely. So now if I want to access that particular data which is stored remotely all across the globe, I want the internet to be high speed. So it has to provide you the high data rate. So to achieve this particular functionality, they are going with the project called as Kepler project. So this particular Kepler project, what it does is, so it is going to made available as remote data sources, which is available for high capacity. Okay. So these are some of the challenges which they have been addressed in your eyes when they are using the early uh, invention of your data intensive computation. So we are going to have the generation or consumption of high rate and high volume data flows. Okay, so human interaction management should be there. The aggregation of dispersed source should be there. Distributed cache capacity should be there, and guaranteed network capacity should be there. Okay, so next comes the data grid. So what the data grid? So with the invention of data grid, so before going for the data grid, so let us tell something about the data grid. So why require the data grid? So grid is nothing but what? So where it is going to store some data. Okay. So now after storing the data, they are going to provide you some services. So now you are going to have the electricity grid, right? So in some of the places in Bangalore, in some places you can see that the grids will be there. So like if you are familiar with the Bangalore, you can have that particular grid is there in Yelanga also. The grid is there in Rajnagar. So what it is going to store with respect to the grid, that what it is going to have with respect to that particular grid. So they are going to store the electricity, and what they are going to provide after storing the electricity, they are going to give the service to the people. Okay, so the same thing happens in your data grid also. So what it is going to provide you, so the data grid basically provides service users to discover, transfer, and manipulate large data set. Okay, so we are discussing about data computing here. So whatever we are going to talk is with respect to the data only. So this particular data grid is basically provides services helping users to discover, transfer, and manipulate large data set, which will be stored in distributed repositories. And also it will help in creating and managing copies of them. Okay. So it is the data grid provides services. What are the services it is going to provide? So it is going to provide you the service of discovering the data, transferring the data, and manipulating the data. So where this particular data are stored, these particular data are stored in a remote repositories. Okay, so these data set stored in distributed repository. So these are the different services what your uh, data grids are going to provide you. So apart from this one, it's going to provide you uh, the main advantage of data grid is it's emerged as a infrastructure supporting data intensive computing. So it is going to have the infrastructure. So it is going to provide you the infrastructure. Okay, so it will also do the data intensive computing. So there, how it is going to provide you the data intensive computing? It is going to provide you the data intensive computing by leveraging the infrastructure. Okay, by giving the infrastructure, it is going to provide you the data intensive computing. That means the support will be given. What type of support it is going to give? The support what you are going to give is infrastructure. So apart from this one, so your data grids offer two main functionalities. What are the two main functionalities? So the two main functionalities which is going to be is one is high performance. Okay. So high performance and reliable file transfer for moving large amount of data. So as I told that, so why we require the computing has to be done effectively. the computing has to be done effectively, because so it has to transfer the file from one place to another file. So at high speed. So if you are going to have the high speed means what? It is going to have the high performance. So that means whatever, if you take your normal Google search. So if you take the normal Google search, so when you search for some term, what it is going to do, what is the first operation it has to do? So it has to first discover, right? First it has to discover the data where it is located, because if when you search for some technical terms with respect to the some in the Google, so you are putting some word. So when you are putting some word, so whether it is going to locate, whether it is going to search in only one place, no. So it is going to search in the entire database all across the globe. Okay, so whichever the IP address or domain name it is going to look into, so those IP address it is going to retrieve and collect the information where that particular keyword which you are given or entered. So if it is searches that one, then it is going to retrieve that particular. First, it has to discover it, right? First, it has to discover in which are the data centers that particular data, that particular search keyword data is available. Once it is discovered, what you need to do? So I have to transfer to your file, right? So I have to transfer to the location where it has to be displayed. So that is what the data grid has to support you, right? So these things, what it is going to do, it has to be in high performance. Okay. So it has to be provided in high performance. So if I want to write it with respect to this, okay. So if I write and show this particular thing, so how it is going to be shown here. So if you take the data grid, if you take the data grid, so it is going to be provide you the services. So data grid services, what it is going to have. So just to make it as 3 words, you have to remember. One is discover, you have to remember. Other is transfer, you have to remember. And manipulate. So then it has to manipulate. So these are the 3 services which the data computing will be providing you. So discover, transfer, and manipulate. So next, through what it is going to discover, it is going to discover a very large data set stored at distributed repositories. So all these things, that is discover, transfer, and manipulate. So if you take the discover, manipulate, and transfer, so from where it is going to take it, so these are the but so it is going to retrieve the large data set. So it is going to retrieve the large data set. It is going to be stored, okay, which will be stored in distributed repositories. That means the database won't be there in single place. It may be in all across the globe, okay, repositories, okay, which is going to have. So this you have to keep in your mind. So it is going to be providing you the large data set stored in distributed repositories. So now if you take the data grids, so data grids basically it is going to provide 2 functionalities. Okay, it is going to provide you the 2 functionalities. So 2 functionalities which is going to be provided is, one is the high performance and reliable. One is your high performance, okay, high performance and reliable file transfer. So because whatever the data you are going to have, so that has to be retrieved from the distributed repositories, right? So if it is it is retrieving from the distributed repositories, which is located all across the globe, so you should have the high performance and the correct file has to be retrieved, right? So the reliable file transfer should be there. So from moving large amount of data, while moving the large amount of data. So now once you are going to have, so if you take the some functionality, so you should have the scalable replica discovery and management should be there. Scalable replica discovery and management, it has to also provide. So what do you mean by scalable replica discovery and management? Is going to the next question. So now when you are going to have the different database repositories all across the globe, so some of the vendors, what they will do is they will keep the same item in the distributed locations all across the data center. So if I take the cloud, for example, so if it's that the cloud is having the data center in India or Singapore or Australia, now multiple copies will be stored in the different region. Okay. the same copy which is present in Mumbai. So the backup or replica of the same item will be stored in Singapore or in Australia. So now when it is providing this particular performance, so it has to discover that what are the different same copy which is there across the globe, that it has to be searched, or that it has to find it, and it has to retrieve the proper data. So it has to retrieve the proper data. So for what purpose it is going to retrieve the proper data? It has to retrieve the proper data in order to have the easy access. Okay, in order to have the easy access. So a scalable replica discovery and management. For what purpose? For having easy access. Okay, for having easy access, you're going to have this particular functionality. So now, apart from this one, what your data grid is going to provide you? So the data grid provide you the storage and management facilities. Okay, so to storage and management facilities. So it also provide you the. So if you take the data grid, so it is also provide you storage and management facility. Okay, storage and management facility. It is going to provide management facilities. So that means the data what you are going to store, it should be managed. So management facilities is going to provide. For what purpose it is going to provide? To support the experiments. That is what type of experiment it is going to support? It is going to support you the scientific experiment. Okay, that word you have to keep in your mind. Scientific. So it is going to support you the scientific, to support scientific experiment. It is going to support your scientific experiment. Okay. So now in the scientific experiments, what will happen? You are going to generate huge amount of data. Okay. So when you are going to do some cloud, that is weather prediction may be there, or when the wind speed may can take earthquake, we are going to have. So this will generate enormous amount of data. Depending upon the data, have to predict, right? So for that particular purpose, your data grid has to provide these things. So now all these data which are there in your scientific experiments, so those data are generated globally, right? So if you take the first scientific experiment, so next is data generated globally. So if I'm going to have the data generated globally, so if I want to analyze it, what I need to do first? What I need to do for the data which is generated globally? So it has to bring to locally. First, data should be brought locally. So data should be brought locally. So after bringing it to locally, so it has to be processed, right? So it has to be processed. So that means the information what you are going to get through the web across, which is present all across the globe, has to be processed and stored and made available for experiments and analysis, which is locally, and it must be likely reliable. So that means whatever the data you are going to generate it for scientific experiment, which is stored globally, it has to be locally present. So and it has to be, data should be brought locally, and it has to be stored locally and stored in local repository. So that's stored in local repository, that also it should be have repository. And so whenever you require that data for your experiment purpose, you should require that one. For what purpose you are going to have this particular data? You want the data for analysis. Okay, you want the data for analysis. So that you have to keep in your mind. So you want, for what purpose you require the data? Data is required for the analysis purpose. So first it is going to store in local repositories. So the data is required for your analysis purpose. Okay. So that's why it is going to be used. So now when you are going to have the, apart from heterogeneity and security, so they have, if you take the data grids have their own characteristic and possess new challenges. What are the new challenges your data set is going to provide? So if you're going to have the data intensive computing or data grid, so data grid is going to have the more huge amount of data. For what purpose? For discover, transfer, and to manipulate the data. So for what purpose you are going to have this particular data? These data are used to analyze. So in your, and it will be analyzed for what purpose? What type of experiments? It will be analyzed for the type of this. It will give the support for your scientific experiment. So for that particular thing, so if you want to have that particular experiment to be that experiment and analysis to be performed effectively, first what you need to do, first whatever the data which is stored in the distributed repositories, first it has to bring that through locally to process it, and I have to store that particular data in local place. Once you store that particular data in the local place, so with the help of some of the tools or some of the languages or some of the algorithms, I have to make the analysis. So now once the data is analysis, what I can do, so I can predict. So once the data is made for analysis, I can do the prediction for that particular data. So that is what is happening there. Okay, the prediction can be done. So that is what happening in your data grid services. These are the services which your data grid is going to provide. So next, apart from this particular prediction which you are going to have, so what are the other features your data grid is going to provide is the next topic. Okay, so when you are going to have this particular data, so what are the different other features it is going to provide? So next, when it comes here, so apart from heterogeneous data, so you're going to have the, I am told you that it is going to have the heterogeneity of data is there. So heterogeneity of data is nothing but what? So all type of data it is going to have. That is, it may be a structured, semi-structured, or unstructured. So that means when you are web, there are a number of databases are there, data sources are there. Like it is image may be there, or video may be there. So or it may be a structured data which is having its own rows and columns where it is detailedly described. So those things will be there. So now when you are going to have this particular part, when they are going to have the electronic data, so so when you are going to have it process new challenges, your data grid, what you are going to have, your data grid process new challenges. Okay, your data grid process new challenges. So now what are the challenges it is going to process? So what are the different challenges it is going to process? So the challenges what it is going to have is, one is, when the in the internet you are going to have massive data set, right? So in the internet you are going to have the massive data set. So with that one, and once you have the massive data set, how we are going to collect particular data? So it is going to be collect the data using shared data, okay, shared data collection, right? So you're going to collect the data using shared data collection. So you should have the namespace. I have to take it as unified namespace should be there. So if I am going to collect the data of the same type, I should have the namespace to be defined properly. Now, whatever the data you are going to collect, and if it is stored in the local repository, so now I have to provide the proper security policy for that one. So only certain members should have access to that particular data. So the fourth challenges which you are going to have in your data grid is your access restrictions, which you are going to have. Okay, access restrictions. So these are the four different challenges which you need to have in your. So So due to high-speed networking technologies, so if you take the data grids, so they were normal data grids constitute a more structured and integrated approach. So your data grid will become what? So your data grid, it is the most structured and integrated approach. Okay, it is most structured and integrated approach it is going to have. Okay, so these are some of the things. So there are several grid manufacturers which are there. So several grid manufacturers which are there. So your grid, so several grid are there. Several grids with respect to scientific research. So the grids with respect to scientific research are, one is your LHC grid is there. LHC grid. Second is your bioinformatic research is there. Bioinformatics research. So third, which you are going to make use of is there. So International Virtual Observatory Alliance. Okay, so internationally Virtual Observatory Alliance. Okay, these are the several grids which are there. from where you can retrieve the data, you can discover. So after discovering it, you can transfer it, and after transferring it, you can either manipulate it or you can use it for that particular data for analysis. So that is about your data grids. So anybody having any doubt with respect to data grid? Anybody having any doubt with respect to data grid? So now once data is being generated, depending upon the different sources. So as the data is generated, more amount of data is generated, right? So now when the more amount of data is generated, so where I have to keep that particular data. So if I'm going generating more number of experiment, more number of data, so I need more number of hard disks to be there to store that particular data. So then for me, it will become expensive for me to have that particular data, and I have to secure that particular data or secure that particular hard disk which I'm going to have. To overcome that one, so your data clouds and big data came into existence. Okay, your data cloud and big data came into existence here. Okay, so data cloud and big data. So here the diffusion cloud computing technology supports data intensive computation. Okay, so it also support. So here also it is going to support data intensive applications only. But only thing is what? So it's going to have with respect to the term big data. So when the term big data is coming into the picture, so what do you mean by that particular big data is? So what it characterizes? So why it become most popular? So when you are talking about the big data, so we are going to have uh, so the three terminologies which you are going to have. One is the velocity of the data which is being generating. So the variety of data which is then generated, and the varsity. So these are the three ways which you are going to have in your big data. Okay, three ways which you are going to have. So this you are going to study in your next when you are studying your different subject as a big data. So these are the three ways which you are going to have. One is there will be an enormous amount of data is generated. That is how much velocity of data it is going to have. So whatever the data it is generating, so it is going to have a different varieties. Okay, different varieties of data has been generated. So then different variety of data has been generated. Okay, so that is basically referred as the three ways. Okay, so that is basically referred as your three ways in your big data. So now, so apart from big data, so same when it is going by having the more amount of data has been generated, so it becomes difficult to become complex to work with hand-on database management tools. What are the different management tools or database management tools you are going to have? So it will become difficult for that one. Okay, so to overcome that particular thing, so you are going to make use of your clouds and big data. Okay, so we are going to make use of the data intensive computing. So when the more number of data is there, so if we take the big data, it will be in terms of, so it was the big data starts from petabytes. Okay, so it will start from petabyte, not even terabytes. So it will be starting from petabytes. So when you are dealing with the data which is in the order of petabytes, so you are going to start with the petabytes. Okay, so the data problem, the data intensive problem. So if we take the data intensive problem, data uh, intensive computing problem, so you're going to have, so that can also be found in your application domain, such as in RFID you can have, that is non scientific applications which you're going to have. So if you take the non applications, either RFID it may be having in your web logs, it may have. Okay, so either it may have it through the sensor networks, sensor network may be there, and it may have through social network. Okay, social network may be there, and some of the documents which is called internal record. So if we take with your technologies, so it will be used for your data intensive computing. So next, after data clouds and data big data, so we have to discuss with respect to the technologies which will be helpful for data intensive computing. Okay, technologies which are involved in. So the technologies for, so what are, can you tell what are the technologies which is required for your data intensive computing? When you're doing the computing, what is required? You require the data. So now where the data will be stored? Data will be stored in some place. Who is going to hold the data? Some storage system should be there, right? So who is going to hold the data from storage system should be there. So the data will be held by some storage system. So why we require a storage system? Because you are going to have the popularity of big data is there, and we should have to do the business. So to do the business, you should have some growing importance of data analytics should be there, right? So now, so first is you require storage system because of big data. Okay, popularity of the big data. Second, you are going to have importance of big data in importance of big data in business domain. So you are going to have the business domain. So in that one, what are the importance you are going to have? Next, and you are going to have the data in several forms. So data in several forms is either it may be a structured data or unstructured data or semi-structured data in each other. So for the overcome this one, I should have an efficient file system to store this particular type of data, right? And if it has to process, okay, I have to process this particular data and I have to use that particular data to have this particular term. So new technologies and new approaches and technologies are required, okay, to store and process new technologies. And so new technologies and approaches are required. Okay, new technologies and approaches are required. So now when you are going to have this particular technologies which you have for your storage system, if you want, so then you are going to make use of what? You are going to make use of it distributed file systems. Okay, so there you are going to have your high performance distributed system. So high performance distributed system is required. So if you take the high performance distributed file system, so if you take the high performance distributed file system, so there are several examples are there. So which are used, which one is Lustre, second is your IBM general parallel file system. So these are prescribably they are going to make use in your cloud only. Parallel file system, parallel file system. Next is your Google to store its own data. It is going to make use of the Google file system. Okay, Google file system. Next, you are going to have the sector. So the last one which you are going to have is Amazon S3. So where the S3 stands for simple storage service. Where the S3 stands for simple storage service. Okay. So this is how the data will be stored in your big data. Okay. So if you take the Lustre is mainly a parallel distributed file system. So if you take the first is the Lustre, so just I will brief it out. So since we don't have an ample amount of time, so it is going to have the massively parallel distributed file system. So here, so it is this particular file system is mainly used. If you take the Lustre, so if you take the Lustre, it is mainly used by whom? It is mainly used by, so it is parallel distributed file system. That means this file system is distributed all across the globe. Okay, so next it is going to have, it is used by top 500 supercomputing systems. Okay, top 500 supercomputing systems, right? So and this particular Lustre is designed to access 2 petabytes. Okay, it is going to have the access to from file system which is going to have the data, right? So what it contains, so this particular Lustre contains, it contains metadata server. So what is meant by metadata? Metadata is nothing but data inside the data. So if a metadata if you take, so metadata is data within data. So data within data you are going to use for security purpose, or if you want to use for the proper retrieval of the data, so from the file system. So this contains the metadata information of file system. So whatever the file system, it is going to be stored here in your Lustre. The file system follow POSIX complaint. So what do you mean by POSIX complaint? Can anyone answer? What do you mean by POSIX complaint? Compliance. So if we talk about the POSIX compliance, POSIX is nothing but what? Portable operating system for interface. So portable operating system interface. So it is similar to your Unix. Whatever the file system you are going to have in your Unix file system, the same file system it is going to follow in Lustre. So because your Linux will follow the POSIX compliance. Okay. POSIX stands for Portable Operating System Interface. POSIX. So if you don't know, you can take it. Okay. So POSIX stands for Portable Operating System Interface. So POSIX is Portable Operating System Interface. What you are going to have. So most of it is a Unix is there, so which will follow that particular file system. So next is your IBM parallel file system. So this is a high performance distributed file system. So this is also, if we take, is also what? So it is, this particular file system is also a high performance parallel file system. So if you know the file system properly from your OS concept, then this particular part is not that much difficult. Okay. So only thing is you should know how the file system works. So it is going to be built on top of the shared hard disk where a collection of disks is attached to the file system. So it is made by switching fabrics from one fabric to the other fabrics where it is going to be switched. So next, this is transparent to users and it is going to strip large files over the disk array. Okay. So disk array is nothing but what? So it is going to be array of disk where it is used to store large amount of data. So disk arrays you are going to have. So whatever the disk array it is going to have, so that disk array is going to store the data. It's going to store the data up to petabytes. Okay, it will store the data up to petabytes. Okay, so that's what it is going to have. So next is your Google file system. So if you want to make use of the Google file system, so it's going to have the storage infrastructure used in execution of distributed application in a Google's computing cloud. So if you take the Google file system, so this particular file system is used for only for Google purpose. Okay, so the data which you are going to get in your Google search, it is enormous. Okay, so the storage is nothing but a storage infrastructure. So it is nothing but a storage infrastructure which you are going to have. So whatever the storage infrastructure you are going to have here, okay, so that is used in what? That is used in execution. That will be used in execution of what? Execution of distributed application which you are going to have. So distributed applications it is going to have in where in each environment. So it is used only in Google computing application, Google computing cloud. So that means whatever the data your Google is going to be stored, so that particular Google is stored in which file system? That is going to stored in Google file system. That you have to keep in your mind. So it has been designed with following some of the assumptions. So whatever the data built on hardware that often fault tolerant. So it should have the build. That means your Google is going to run 24/7. So that means it should be fault tolerant since it is going to have run. So and it should have store large files should be there. Stores large files and it has to be stored effectively and it has to be retrieved effectively so that it has to be minimized. So it has to be having when you want to retrieve two types and read the data. So two types of read it is going to support two type of read. So one is your last stream read. Last stream read it is going to support. Other is random read. Large stream read or small random read. Random read is what it's going to directly access the data from that particular part. If not, it will become sequential. So that is what about your Google file system. So next is sector. Sector is similar to the sectors which have been studied in your operating system file system. Okay, so in your so next is Amazon SQL storage service. It's an online storage service provided by your. So if we take the Amazon AWS, if we take, so it will take the online storage service. Okay, this is going to provide you the online storage service. So what it has to provide, since it is online, it has to provide support of high availability, scalability, and infinite storage. Okay, so it has to provide the infinite storage. So all these things will be in terms of, it's going to be providing, is also provide you the flat storage space. Flat storage space it is going to have. So that particular flat storage space is called as buckets. It is called as buckets, which you are going to have. Okay, once you have the buckets which are attached to, these buckets are attached to WA, Amazon Web Services. So this is attached to Amazon Web Services. This is attached to Amazon Web Services. So each bucket can be having multiple objects, each of them identified by the unique key. So they will be having the unique URL, and they are going to access through HTTP protocol. So these buckets which you are going to have can be accessed through HTTP protocol. Okay, so this is going to have. So since it is used HTTP, so the disadvantage is it is not secure. So it is not secure. So these are the some of the storage system or Google file. These are the some of the file system or storage subsystem, or which is nothing but a high performance distributed file system, which is used for your data intensive computing. Okay. So anybody having any doubt till now? If you have any doubt, you can ask. Okay, if you have any doubt, you can ask. So till here, your syllabus will be there. So I will post the questions